Hello everyone, my name is William, and in this video I'm going to be showing you just a simple implementation of tic-tac-toe in JavaScript in the web browser. So if you're new to programming, this might be something for you. If you're experienced, it might be fun as well to just try and implement this. Just a simple tic-tac-toe game, and well, you're going to learn a little bit about like 2D animations in the browser and stuff like that, and just in general like some basic control flow and stuff like that. So it's going to be exciting. So let's get right into it. So let me switch here. So as you can see, we are in the browser right here, and we are on a website called editor.p5js.org, and you can go ahead to this website. You can press on file and you can press on new, and make sure to get an account so you won't lose the things you actually create. So sorry about the noise from my computer. I can't really do anything about it, unfortunately. So some of the things you will see here is that 1 second, sorry, is that you have 3 files here when you make a new project. So you have some styling, then you have an index file where you can see that the P5 library that we're using, it is actually linked right here. You can see the P5 library as well as some DOM, P5 DOM, and some sound functions you will have access to. And if you want to add new files to your project, you can do that by copying this line right here. So it's all good. So basically what P5 is well, it's a library that allows you to make easily draw to a canvas in JavaScript. So well, the setup function right here, that will run once the program is run, and the draw function will run 60 times per second. So what we'll see if we run this, we'll just see well, a gray background. If we actually go in like and do something like this, and just say okay, on the 10 on the x-axis, 10 on the y-axis, and it should be 100 in width and 100 in height, and we will draw a rectangle. You can see that it draws a rectangle, so just very basic like that. Okay, but for tic-tac-toe, we don't actually want to like update the canvas 60 times a second, right? We only want to update it when you actually click on the actual thing, right? So we can actually just go ahead and delete this, and so the first thing we're going to do is to figure out how do we want to represent the information that is in the canvas right here. So let me just go ahead onto my sketch right here, and let's draw a simple form of a grid that represents the tic-tac-toe board, right? So in all of these different positions, we can either have an X or a circle, right? And in this case, I'm just gonna color basically just gonna make them like blue and red instead. So that's the difference, because it's way easier to work with like color instead of making custom shapes. So that's what we're gonna do instead. So well, how can we represent this? Well, what we can do is actually we can look at the rows, which we can represent the indexes of the rows, or the columns, sorry, by that, and then we can represent the rows like this. So it's actually well, a 2D array, or you might call it a matrix, right? So it's basically a list with three lists inside it. In a way, it's not really a matrix. So let's implement that. Okay, so we want to have a list which we will call map, and this list should contain 3 other lists, and for each index, like for each position, we will give it the value 0 to start off with, because that, well, we decide what it's called really, but we will say that okay, if it says 0, it means that well, there is no one on this position on the map. So alright, next thing is that well, we have as you can see right here, we are actually creating a canvas of size 400 times 400, and we're not drawing anything in it right now. But how do we actually draw these positions? Like what is this, the size of this? Well, if we know the total size of the canvas right there, it is 400, then this one, which we'll call W, will be equal to 400 divided by 3, which is well, around 133. So let's implement that. So we will make a variable called W. We will set it, not set it equal to anything right now, and then we'll go here and we'll say, okay, we'll actually initialize W when the canvas has been created. We can initialize it, because then we can use a variable called width, which will refer to this value. Essentially, it's built in p5.js. So we can say, okay, W is equal to width divided by 3. So okay, so that's cool. So next thing I think we want to do is just get it up and running. Let's actually visualize it. So we'll say, okay, for let I equals 0, I is less than 3, I plus plus. And then we will, inside of this one, we will loop over the rows, right? So we'll say, okay, let j equals 0, and just like before, j is less than 3, and j plus plus. And this, we're essentially looping over all of these positions, right? Because we are going over the rows or columns or whatever. We're going over one of them first, and then for each element in this list we are going over that. So we can actually say that we want to draw a rectangle at the position. What should that be? Well, the position, I believe, should be I times W, that's the x-axis, and j times W, because then you can see, okay, when j is equal to 0, then the position will be in the top left corner, and then every time it will move by width. So you will see it makes sense in just a second. And then obviously the size of these rectangles that we draw with this function will be width. So let's go ahead and do that. And as you can see, it works. So we are getting like 9 squares right here, which is nice. So and yeah, again, let's just one second. I just want to make it take up a little less space, my code. So just like this. That's the same thing. So when you're doing it on one line, you don't need these well, squared brackets really. So that's just a nice thing to know about. But we also don't want to make the lines too long. So anyways, so what we want to do now is actually say, okay, so what should happen when someone clicks on the canvas right here? Then we should obviously change the color to either blue or red, right? Depending on whose turn it is. And what we will do is we will represent the person or the color that is on a field by either 1 or -1. So that will, 1 we could say is X, and -1 is the O, the circle, right? So but obviously it's 0 to start off with. but what we can do in p5.js is we can use the function called mouse pressed, which doesn't take any arguments, but it's a very smart function. Well, essentially, this function, when it's defined in your script, in your sketch.js, it will run every time the mouse is clicked. So we can test this. Let's just do a console log, which will just essentially print it in the console right here, and just some random things, so we can see that, okay, when we clicks the canvas, we can see that it actually prints WD down there. So this was just random. So let's go ahead and delete that again. So it works. Nice. So what do we want to do when the mouse has been pressed? Well, a couple of things we want to do. So we want to find out in which position of these 9 positions has the mouse been clicked. So that's the first thing that we want to figure out. And yeah, let me go ahead back here. So what we would like to do is to map a position. So we will call it a position on the x-axis, for an example. It goes from being greater than or equal to 0 to being less than or equal to 400, right? And we want to map that to be between 1 and 2, because that's the indexes. So how do we do this? Well, what we can say is, okay, we can make a fraction that says the mouse x, or what? No, never mind. We'll keep on calling it pose x, which is the position of the click on the x-axis, divided by width, which is, as we talked about, that's equal to 400. So we'll get this fraction that represents, like, from 0 to 1, where are we on this on the x-axis. Now what we can do that then is to say, okay, well, we can so we have this fraction, and what we can actually multiply that by the width divided by w, which was this one, as you remember, for the width of 1 square, right? And the reason why this makes sense is because then we know, so we get how many essentially squares there are, right? And there'll be this will equal 3, right? So this part will be 3, and this will be from 0 to 1, right? And yeah, so when we multiply these ones, we'll get a value between between 0 and 3, although it only equals 3 when the actual point you're clicking on is all the way is 400, because then this over here would equal 1, and then the total would be equal to 3. So that will be a case that we are not going to take into account, but we just need to be aware of it. So essentially, if we click right here on the edge of the canvas, we will get an error, an index out of exception, but we'll not. So let's assume that it's between 0 and 2, because it's very rare that this fraction actually becomes 1. That's like, it's never gonna happen, right? So but what we can actually see right here, what we can observe is quite easily that width doesn't have to be included. We should just be able to say that this should be equal to pose x divided by w, right? Yeah, that should be basic math. So let's try to implement that. So we will say something like, okay, let we will do what we'll do. We'll do the row, we'll call it. No, this would be the column. I think that's how you spell it. Is equal to, and what was it? Pose x. So mouse x, that's equal to pose x divided by w. I think it works. And what we actually want to make sure as well is that when we do this, we will, as we discussed, get this value between 1 and 2, 0 and 2. But what we want to make sure is actually that we are only dealing with like whole numbers, 1, 0, 1, and 2. So we will do a integer conversion like this, and again copy this, and this will be the row where we will use mouse Y, obviously. So what we can then do is that we can say, alright, so if the value in the map is already a not 0, if it's not 0, then we should not change, then we should not, cannot position then we cannot use that position when we press the mouse. So we can check to see if map index column index row equals 0. So if that's the case, then we can proceed and we can say that map index column index row should be equal to something. And what is that something? Well, what we're gonna do is we're gonna keep track of whose turn it is, and we're gonna call it what could we call it? Turn, right? And we can say, okay, to start off with, the turn is 1. No, we'll say, okay, we'll actually say the turn is -1 to start off with, and then when you press the button, turn will be equal to turn times -1, so it will reverse it, right? So it will become 1 in the first, when the mouse is pressed the first time, and then we'll say that map equal to turn. However, if it already has a value that is not 0, oh, this is not a string, sorry. If it's has a value that is not 0, so -1, 1, then we don't want to lose our turn just because we misclick on the wrong position. So we will actually say that turn, and again, let's just make this shorter. So turn should be equal to turn times -1, like this, so we don't lose our turn. Alright, so this should work. So what we can actually do is let's go ahead and console log the map like this every time that we click the button. So let's do like this, and let's go ahead and look at it. So I don't know where we clicked. Oh, look at that. So it actually turns out we click on this position, it seems, because it's row 0, as you can see right here is row 0, and it is element 1, which is this one. So let's try another one. Let's click in the middle. and what we get is that we would expect it to be in the middle right there, and yeah, that's right. So it does seem to be working right now, and it says -1, which is also correct, right? Because in the first turn it was equal to 1, as you can see. It was equal to 1, and then the next turn it was equal to -1. Alright, so next test we want to do is to say, okay, if we click in the middle again, then it should not change the value to 1, which is the next turn. So we'll click there. Let's check number 1, and we can see it's still equal to -1. So that's all good. Now if we click here, we should also not have lost our turn, so it should set the value of index 2 and index 2 equal to 1. So we have not lost our turn as well. I hope this makes sense. Otherwise I'm just gonna visualize it now. So what do we want to do? Okay, so every time that a change has been made, we actually would like to visualize it. So let's just comment visualize right here, and we will go through like this. So we'll say just like we did over here. So we'll actually just copy this, like that. Like that. So we'll say, okay, for all the values, for all the rows, all the columns and all the rows, we'll draw a rectangle. So okay, so let's go ahead and do this, and well, we will observe that absolutely nothing happens when we click it, which is fine, to be honest, because we have not implemented it. So we want to say that, okay, we have 3 cases, right? The value of the map could either be 0, or it could be what could it be? A -1 or 1. Oh, I just realized something, to be honest. So we actually don't have to loop over all of the what is it called, positions, right? We only, when we update the position, which is done right here, we just want to actually update the to draw something properly. So what we will actually do is that we will say, okay, yeah, well, if turn equals 1, then what color do we want? Let's just say red. Okay, so if turn is 1, then we will draw at and this will be column times W and row times W, which will give us the mouse X position, right? Because then so what we got was that we said, okay, we get a column which we'll call C is equal to mouse X divided by W, and as you can see, we can transform this into C times W, which equals mouse X. So this is why we will say, okay, column times W, and it makes sense intuitively as well. And what is the width of them? Well, it's W. So let's do this, and what we'll do then is we will say, okay, so what we'll do is we just need to draw the rectangle, but the color of the rectangle should change, and the way we do that is with a fill function. The fill function is from p5.js and basically just says that, okay, set the current color that we're drawing with to be something, and what we want to set it to be is to be red, so it's RGB, right? So red is 255 on red and 0 on green and 0 on blue right there. So let's go ahead and try this out. Boom, it draws a red one, but it draws a red one all the time. That's because we're not actually changing the fill after when it becomes -1. So let's go ahead and implement that. So we just copy this line and we'll say, okay, if it equals -1, then we will make it blue, which is this one. Oh, and how about that? So it actually works. That's pretty cool. And as you can see, we cannot override what has already been clicked on, and that's very convenient. So that was only like under 10 lines or something like that to implement this logic. So let's think about this. Okay, so what is the next thing we would like to do? Well, we essentially just need to now that it works perfectly, that people can they can position the pieces on the board. It works great. We just need to check if there is a winner. So we will say, okay, so we need to write a function essentially that checks if there's a winner, and we'll call this check for winner. We'll call it that. And how are we gonna check if there is a winner? So obviously we could do this the easy way. The easy way is just that we need to and it's a slightly optimized way. So let me just change the colors to something else. So we need to check these three pieces, these three, and we need to check these three, and these three, sorry, and we need to check the horizontal ones just twice like that. So that will be like let's take another color. So that will be 1, 2, 3, 4, 5, 6, 7, 8 checks. And there is a smarter way to do this, which you would use if you have what is it called, 4 in a row, where you so let's imagine we have the board that looks something like this, where you have like a bunch of rows like that and a bunch of columns, and then you drop down like then you just drop down like these things that will land in the bottom right, and then you need to check if there are 4 in a row. So that game, you would not do these checks manually. You'd actually write an algorithm that could check this universally. So I might look at that later, but just to start off with, we want to keep it easy, alright? Let's just implement this manual way of just checking each of these different states. So what do we want to check? Well, we would like to check this in a slightly smart way. So let's just think for a second. Yeah. Alright, so what we want to do, this is going to be quite a long and annoying function as well. So we want to say, okay, for let I equals 0, I is less than 3, I plus plus. So for all of the columns, we want to go through all of the rows. something like this. The reason why I'm being quiet is because I'm thinking if there's a smarter way to do this, because it's a bit of an annoying way. So I think we'll see, okay, if we are basically looping over the rows right now, right? So we are taking each of these, let me just create a new page right here, so and get it the right color. That's it. So so basically what we are trying to do is we are looping over the rows right there, and for each row we want to check these horizontal lines right there. So that's what we're gonna do, and the way we will check that is that we check, okay, and we see, okay, who is the player on this, on the first element in the row, and then we just check the last two ones to see if they are also equal to that. So yeah, we'll only have to do 3 checks, so we'll just do this manually. Okay, so we'll say, okay, let player equals map index I index 0, right? So that will be the player. It will be either 0, it will be either what will be like 0, -1, or 1. So what we should do is that we'll check, okay, if map index I index 1 index 1, if it does not equal player, then we know that this particular column does not contain a solution or a winning position, right? So in that situation we're gonna keep track of no, what we'll do is actually we'll say, okay, if it equals the player, then if it does not equal the player, then we will break the for loop. No, that we shouldn't do that either. So we could do this. We will take a look at a variable called found, which will be equal to true, then say, okay, if it is not equal to player, we'll set it to false, and we'll obviously also check the other position, which is kind of redundant if this is already true. So we'll say, so we'll say, okay, then found equals true, right, false right there, and found equals false. So those are those two, and then we will say, okay, we will say that if found, so if it is true still, then we want to return the player of this row, so we know who has won, right? So this will actually so this should basically check all of the rows, so we can test this. And what we'll do is that we will return 0 if no player has won. So what we can do in our mouse pressed function right here is to say, okay, so we will just do a variable called potential winner, I think, which should be equal to check for winner, like this, and yeah, so then we'll say, okay, if potential winner, just copy this, if it does not equal 0, then we know that there's a winner. So what should happen then? Well, then we will keep track of whether there is a winner or not by a variable called isWinner, which we'll set to false to begin with. Obviously there's no winner when you start the game, but when it is potential winner is not equal to 0, then the then isWinner should be equal to true. Just like that. And what we will also do is that we will draw some text, I think. We'll just comment that and we'll draw the text later. So we should display some text which says, okay, someone has won. For now, we can just console log to test that it works and see, okay, if there's a winner and winner is, and we'll do a space and we'll do plus potential winner, right? So now essentially it should check the rows and see if any of them are filled up with the same colors. Let's try this out. Let's place a red right there, we'll place a blue right there, we'll place a red right there, and we'll place a blue there, and we'll place the red right here, and we hopefully, boom, the winner is 1, and 1 is the red one, so it works. Brilliant, brilliant, that's great. Okay, so this part works. It actually checks the rows, but we also want to check the columns right here, right? So we want to also loop over the columns and check these rows right there. So we want to loop over the rows and check the rows, yeah. So we will basically just, and this is why this is a stupid way of doing it. It doesn't matter when you do well, what's it called, tic tac toe, because there are so few options. But if we, let's say that potentially you could make something called n on a row. So imagine you did n on a what's it called? No, tic tac toe. Right, tic tac toe is there's 3 elements, but if you had n elements, so imagine that you had like a board with loads of these squares, right? Then you would, if you would want to check if there was someone who had actually placed axes on this one, you wouldn't want to manually check all of these. Well, it could be done actually somewhat of the same way, but yeah, essentially there is a better way of doing it. As I explained with the example before with this particular game over here, that yeah, if you'd want to check in on a row, then there is a much smarter way of doing it. But it's okay. So we'll do this again, but this time we will actually say, okay, well, now the I value should not be the row, it should be the column right there. And we'll just change it. It should not be the, sorry, it should not be the column, it should be the row instead. So we'll change the rows, check each row. So again, we'll do 1 there, the I, so we'll just basically change them up like this, and that should be it, to be honest. So let's test if it can check now the rows. So let's, for an example, try to click right, let's place a red there, blue there, a red there, and a blue there, and a red here, and we should see that there is a winner now. Winner is 1. Perfect. So now we are able to check. So now we are able to check both these rows and the ones that are on the columns. We can check the columns and the rows. So that's brilliant. We just need to now check the actual diagonals. So how do we do this? Well, it's actually quite simple. So what we want to do is the same thing basically, but instead of we're just gonna loop over. So I'm gonna delete some of these things, alright? So what we're gonna do is we're gonna grab these two. Gonna grab okay, so we don't need the for loop actually. So just get rid of all this. So okay, so we'll say okay, so the first thing we want to check is the element that is on this position right here, right? That position we'll check. Then we want to check this position. We want to check this position, and we'll actually just do it manually. So we'll just check. Okay, we'll set the player to be equal to that, and we'll just basically check twice, and we'll copy found, put it right there. Okay, so we'll say okay, well, and then we need to check these as well. So if they do not equal player, then found is false, and again, if found, then return player. And so now it should be able to check this one, this diagonal, and we'll just copy this piece of code, paste it in here, and now we have already initialized these, but we'll just reset the values right like this. So now we'll instead check index 2, so that's the one over here. We'll check that one, right? It's the one here. No, sorry. So it'll be 2 on the rows and 0. So it'll be 2 over here, but 0 on the rows. And then we will check the one in the middle, obviously, again, and we will check the one that says, okay, it says 0 on the columns, and it says 2 on the rows. So that's the element that is right there. So we'll check these 3 and return if it's been found, otherwise return 0. So let's see if this actually works. Let's see. Okay, well, we'll place a red one there, we'll place a blue one there, red one there, a blue one there, a red one there, and a blue one there. Boom, winner is -1. So perfect, so that actually works. So it's able to check diagonally like that. So that's basically it for our check function, right? So now all we need to do is to say that, okay, draw some text when someone wins. We'll do that just in a second, but basically, as you can see, okay, even though the blue has won, we are still able to actually place more of these place more I don't know what it's called, pieces, right? We're able to place more pieces. So we'll say, okay, we should only continue when the mouse is pressed. We should only continue on the next line if not is winner. So if is winner is false, right? That's what it means when you put a exclamation mark. So then we should continue, but if it is true, then we can just, well, return and stop the function. So let's try this again. So let's just put some pieces right here and like that, and we see the winner is 1. Now we cannot place any more elements. Oh, the battery is running low. How much battery have I got? 10 minutes. Jesus. I need to drop in the charger. That's it. Alright, brilliant. So now there's only one thing left to do, and that is to draw some text. So we will say that, okay, And the way we draw text is that we can say text, and then it will draw. The thing is, my computer starts like, it just goes crazy when I plug in the charger, like the fans. I hope it's alright. I'm really sorry. So what we can do is, I think the argument it takes is the text, and then it takes a position, which we will say it should be right in the middle, right? So we'll say width divided by 2, and then minus a little portion. And the reason why we want to minus, like, maybe we can minus like v2, like something like this, is because the text is drawn from the center. So essentially, let me just show you this. So we go to new one, and let's say we have a canvas right here. So we have a canvas, and essentially the X value, they run over here in this direction, and the Y values, they go like this, where we have 0, then we have 400, right? And we have 0 on the X-axis right there, and 400 there. So basically, if we say, okay, width divided by 2, and height divided by 2, that will be right in the middle, but then it will actually start writing the text here, right? So the text will not be centered, so we need to move the text in this direction in order to be centered. So I'm just moving it by a little bit, so that it's pretty much centered right there. So that's why I do this. So that will be the X value, and the Y value will be this, which is perfect. And then the text we want to write is, we could say winner is, and it could be winner is red, right? But when is the winner red? Well, that is only when that is only when sorry, if potential winner equals 1, otherwise, so that is else. We can just say else, right? So we say else, then winner is blue, but you should draw it in the same place. And we can still console log this, which is fine, and this should be pretty much it. Although we might want to change the text size to make sure it's a proper text size, and let's do 32. Don't know if that's a standard or something it can actually measure. So let's try this. Play some. Boom. Winner is red. Okay, so it doesn't place it in the middle. Okay, and that's obviously because we shouldn't subtract anything on the y-axis. So let's try again. Oh, sorry. Oh my god. That's it. So it says winner is blue, and we forgot to delete it right there. And as you can see, that the colors actually are. So we want to say, okay, fill 0, which is black. So let's try that if it looks better. So we say okay, boom, and then it says winner is red. I think white will be better in this case, based on the background. So let's see. Well, winner is red. That looks pretty much alright, and it print winner is 1. So yeah, that's pretty much it. Now we have created Tic Tac Toe, and it was pretty easy, right? So it is only like it's like 74 lines. It's nothing. We can probably like even get it down to take up like only 50 lines of code. Let's actually do that. So then then I can make the title of this video be make a tic-tac-toe in 50 lines, which should be cool. And we can delete the console log, and that's not needed. What else can we do? Well, these values, we don't actually need to save them right there. Yeah, I don't know. Let's see, how many lines are we at? We are on quite a lot of lines, so there's a lot of redundant spaces here, which I will delete. What are we at? 67 lines? Can we get it down to 50 lines? That would be nice. So let's remove redundant spaces. I know this is totally unnecessary, and we can cram this into like in one line. So this will be exactly the same. And now we are at 59 lines. We're almost there. So what can we do? Well, we can put this one on one line actually as well. Oh, that's it. Now we are at 57 lines. And what we can also do is we can take this part, right, and we can just drop it in where it says column. This is column there as well, and this is column there as well. So I know that this is completely stupid, because then you would have to calculate it multiple times, but it doesn't really matter because you don't need speed when you're playing tic-tac-toe. Like, you don't need any significant speed. So this is bad practice, I will say, but I just want to get it on 50 lines. So let's get rid of these two. This is just like, it still works perfectly. 55 lines. Are there anything we can do? I feel like this check for winner function is actually like really too long. Like it should be possible to maybe remove some of these, I believe. Yeah, so what we can actually do is, with all of these if statements, we can actually say or right there. So if either of that is true, then it should do that. And the same goes for this one. So it will be, we'll just put it into one if statement like this. Again, so sorry about my computer, it makes all those noises. So 52 lines, and the same goes for this. So to say or like that, and do this, and same goes for this one. And now we should be far under 50 lines. No, exactly 50 lines. Well, that's perfect. So let's check if it all still works. The lines are not too long as well. So see if it all still works. Oh, it does not. How inconvenient. But it actually does like find a winner. It just doesn't. What is wrong? So now I'm just really looking through this to find the mistake, to see what it could be. This all looks right. I don't see what would be like wrong with this part. Like I don't see that. But it does actually register that there's a winner. So what we can do is say, okay, well, in this one, console log winner. So let's just see if it actually is able to register that there's a winner. So let's just winner is red. Apparently that worked. It just didn't work before. That might have been a mistake on the website. Winner is blue. Okay, so it does work apparently. And what is this? 50 lines. Perfect. Winner is red. Let's try horizontal as well. Winner is red. It all works perfectly. So that is all good. Yeah. This is pretty good. I'll put the code in the description so you can go ahead and test it out yourself. And yeah, I know this is a very long video actually, and I realize now that I'm looking at this that my head has been in a weirdly position that is not maybe so nice to look at. But anyways, this has been fun, and I should really go to bed now because it's way too late. So yeah, I hope you guys enjoyed the video. Maybe it was too easy for you. If you coded before, this was a pretty easy project. I just wanted to do something quickly, just maybe help out some people who want to learn programming. Then I really recommend a guy called Daniel Shiffman. He does P5 JS tutorials and loads of other videos that are really nice. So go check him out. I'll leave a link in the description. But well, if you like this video, then I suggest as well maybe checking out. Well, I don't have that many other coding videos, but maybe you could subscribe and comment if you want to see more of these videos. And also, well, if you feel free to drop a like and all that if you want to. But yeah, I'll see you next time. Bye.